Hi, in this video we are going to learn about the general search algorithms. General search algorithms, here it's meant for searching for the solutions. We can find a path or route to the goal state, and we will enter into a lot of steps during the course of search which are known as intermediate steps. The state space is generally defined as a combination of this SAIG. They stand for the set of nodes or states, and A for set of arcs, I for initial states, and G for goal states. The solution path is the path through the graph from the initial state to the goal state. The state space search is the process of searching the state space for a solution to reach the goal. This is an example of how we can go for searching a solution. Let A denotes the initial state and Z is the goal state. This is representing the robo. These are all the open doors through which the robo could move, and this represents the wall. For example, if the robo is in room B, it can move to the adjacent rooms A, C, and E. This tree completely represents the possibilities in moving and reaching the successive nodes. For example, if it starts from A, it goes either to B or D. So from A, B or D are the possible moves. From B, the possible moves could be to the adjacent rooms A, E and C. From C, the possible moves could be to B, which leads to a loop state, and Z, which is the goal. Problem solving agents. An agent is an entity that can perceive the environment. It has an ability to perceive the environment. After the perception, it will act according to the situation. It will give you the desired results. The various steps involved in describing the process are the goal formulation, number 1, the problem formulation, number 2, and number 3, sequence of actions. You're going to make a search with a given problem, and finally action on the sequence. Finding the goal, then the problem and search, and finally the action. The control strategies. It tells you how to reach or what way to follow while searching for a solution. There are 4 strategies: forward search, backward search, systematic search, and heuristic search. So these are the 4 control strategies. The first one is the forward search. Here in the forward search, we can reach a solution from the initial state, and the methods employing this strategy is referred to as data directed ones. For example, consider a robo navigating through a maze to find the exit. Generally, the robo will start from the initial position and it is exploring the adjacent cells, then systematically moving forward until it reaches the goal cell. At each step, the robo selects the next cell to explore based on the predefined rules or heuristics, such as always going to the cell with the shortest distance. And number 2 is backward search. From goal to a solvable initial state, and here the methods employing this strategy is referred to as goal-directed ones. For example, a diagnostic system where we are going to identify faults. Here, the system starts with the observed symptoms, that is the goal state, and systematically traces backward through the relationships between the components until it identifies the faults. That is, comes back to the initial state. Number 3, systematic search. Here, the search space is small and systematic. The search has no information about its domain. For example, locating a particular book in the library. Here, the books are not indexed, and we start from a designated section and we are systematically searching through the shelves row by row until we find the book that we want. It's a systematic search. Number 4 is heuristic search. This technique is based on the previous experience and proper guidelines. This technique improves the efficiency of the process. For example, yard distance of the city from the current location. Generally, this approach is used in the systems having time and space constraints. The GPS uses heuristic search algorithms to estimate the time or distance to each potential route and selects the one that appears to be the most promising, and it is based on some criteria which may include shortest distance, then fastest time, and least traffic congestion. The control strategies or the parameters for search evaluation includes completeness, space and time complexity, optimality, and admissibility. Actually, the control strategy should execute in a defined finite time, and it also need to consider the memory and the time constraints. Also, it should be capable of giving an optimal and good solution. These are all the parameters for search evaluation. Thank you.